Okay, we are solving trigonometric equations. We will have a test on this on Friday, and after we've gone through it a little bit, you'll see it's not as difficult as it looks.
This Friday?
This Friday, I think y'all can do it.
No.
I think you can.
Friday.
Huh, there's no pepper alley. What? Oh, good try though. No pepper alley Friday. All right, so y'all, let's think about this equation. Instead of it being sine x right here, let's think about the equation from Algebra 1 that you would have seen that was 2x plus 1 equals 3. Now, everybody in here knows how to solve this, right? We're going to subtract 1, all right, and then divide by 2. So you get 1, don't you? Okay, just because you have sine of x there does not change that process. Instead of just x there, you've really got that sine of x that you're going to solve for. So same process, you're going to subtract 1 over. So you have 2 sine x equals 2. Y'all see how it's working the same way? Divide both sides by 2. So we have sine of x equals 1. Now this is why you have out your unit circle. Because what I need to know is, well, what x value can I put right there and say sine of that angle and I get 1? Pi over what? Pi over 2. Because around the unit circle, we're looking for those y values that are 1. Y'all remember that sine was y and x was cosine, isn't it? Do y'all remember that around the unit circle? And y was sine. So I know which ordered pair to go look at. Okay? Questions about that first one? Okay, let's try a second one then. Okay, the second one's going to be 2 cosine x minus root 3 equals 0. Okay, so we're solving for x. Nope, no calculator, don't need it. What's going to be the first thing you do? Add root 3 over, so we have 2 cosine x equals the square root of 3. Divide both sides by 2, so cosine of x is root 3 over 2. Okay, so now go to your unit circle. Look for the x coordinates. That would be positive root 3 over 2. So pi over what? Pi over 6 is one of them. And what would be another one? 11 pi over 6. Where is cosine positive at? First and fourth quadrant. So that's why I need to go look for the 11 pi over 6. Questions about it? Okay, are everybody okay? Thumbs up. Y'all are good? Thumbs up, thumbs up. All right. Let's keep going. Okay, let's try another problem. Let's do tangent squared x. So we're going to have tangent squared x minus 1 equals 0. Let's try that one. Tangent squared x minus 1 equals 0. So again, we're going to add 1 over. Do y'all see that? Still same process. So I have tangent squared x equals 1. How do I get rid of something being squared? Square root. So if I take the square root of both sides, I have tangent of x equals, what's the square root of 1? 1. Now we do need to put plus or minus because we're solving an equation. And each time I do that and I take the square root, you have to put plus or minus. Okay, now look around the unit circle. Where would tangent be either positive or negative 1? Good. every one of those pi over 4s, right? So pi over 4. Then what was the other one? 3 pi over 4. 5 pi over 4. And finally, there you go. Questions about those? Any questions? Okay. Let's go ahead and do another one then. Seems like we're getting it pretty good. Okay, so let's do a fourth example. And let's do sine of x plus the square root of 2 equals negative sine x. Okay, so what's the first thing we need to do? Okay, we can make that equal to 0. We can add sine x over to the other side, can't we? So let's add that sine x over. Sine x plus sine x. So how many sine x's do we have? 2. So we have 2 sine x plus the square root of 2. What's left over on the other side? 0. Do what? If you're multiplying, that's where sine squared x comes from. Okay, adding, you're just collecting your like terms. Right, and so now we're pretty close to the previous problems that we did. We're going to subtract the root 2 over. We're going to divide by 2. So I have sine of x equals negative root 2 over 2, isn't it? After we do all the algebra magic. Is that all right, all right, all right? Yeah. Now go to your unit circle again, because now this is one of those exact values. And where in the world would sine of some angle give me negative root 2 over 2? Perfect. 5 pi over 4 and 7 pi over 4. Okay, questions about it? Any questions? Yes, sir. Here I added this sign over this sign here. Right, you're combining those terms. Okay. Okay, questions about it? Okay, let's try a couple more. Okay, what number would this be? 5. All right. So for number 5, let's get more into the factoring part. So we're going to have cotangent x, cosine squared x equals cotangent x. Well, this isn't writing. Okay, now the first thing students always want to do, a lot of times they want to come over here. Notice my lightsaber, boom, boom, boom. All right, so the first thing kids want to do is try to cancel out your cotangent. You cannot cancel out the cotangent. You can't. You will lose half your solutions if you do that. Never ever cancel out a trig function or that x value. Don't do that by dividing. Do y'all see what I mean? Everybody wants to divide both sides by cotangent x and try to cancel. You will lose your solutions. Don't do that. Well, if I can't divide both sides by cotangent, the only thing left to do is get 0 on one side, which is going to be to subtract cotangent over. So we need to rewrite this so that I have cotangent x cosine squared x minus cotangent x equals 0. But again, do not try to cancel those. You will lose part of your solutions. Okay, questions about that? Right, now let's look. Both terms here have a cotangent in it. Do y'all see cotangent here and cotangent here? So that's going to be a common factor for us. Do y'all remember GCF? How we had to take out a common factor back in Algebra 1? Greatest common factor. That's what we have here. It's like doing the distributive property backwards. So I'm going to take out cotangent x And let's look and see what would be left over inside the parentheses. If I'm taking out that cotangent x from both terms, and think about the distributive property, what would have to be inside the parentheses here? Cosine squared x would be one of them. Minus, what would have to be in the other spot? 1, isn't it? And think about the distributive property. Y'all remember that, where you have to take this cotangent and you would multiply it through to each part? Would I get what I started with if I do that? Yeah, so that's what I was talking about with your GCF. You're really undoing all of that distributive property stuff. Okay, questions about that?
That's the answer.
Oh, not quite. We still got that equal to 0. It'd be great if it was.
The way you said it.
After you have two things multiplied together, this is equal to 0. Back in Algebra 1, y'all were told to set each part equal to 0. So you would come over here and say, well, that's cotangent of x equal to 0. That's one of your equations. And then your other equation would be cosine squared x minus 1 equal to 0. And you need to solve for that x value. Now let's think about what we did on this last test. Cotangent of x is 0. Cotangent's the reciprocal of what? Do y'all remember? Tangent. So what does that mean about tangent of x? What's the reciprocal of 0? Undefined. So I need those x values where tangent is undefined. So let's look at our unit circle. Where would that be at? Pi over 2 was one of them. What was the other? 3 pi over 2. Okay, do y'all agree with that? And notice if we would have canceled out that cotangent, I would have lost 2 of my solutions. So you don't need to cancel it. Okay, now what about this other one? We would add 1 over, wouldn't we? So we have cosine squared x equals 1. How do I get rid of something squared? Square root. What have I got to remember to write here? Plus or minus. What's the square root of 1? 1. Woo! So what x values would I need here? 0 and 2 pi. Do y'all agree with that? Now 0 and 2 pi are found at the same place, so you don't have to write both of them if you don't want to. One or the other would be fine. All right, I went through that one kind of fast. Y'all go back and look. First thing we did, we had to subtract that cotangent over. Then we had to factor out the cotangent. And then we set each part equal to 0. So my solutions, notice I ended up with 4 solutions. You could do 3. Yes, sir?
What about pi?
Pi. What is... Oh, yeah, there's one more, isn't there? Because it's -1, positive or -1. So that's going to be also pi. Absolutely. Thank you, sir. I overlooked the -1. Okay, questions about it? Questions? All right, so let's continue on with the idea of some factoring. Let's look at, let's see, what number would this one be? I really should keep up with that. 6. Let's do some factoring. Let's do 2 sine squared x minus sine x minus 1 equals 0. Okay, so there's an example, factoring. Let's go back and think about, well, instead of all this trig stuff, let's think about what we did in Algebra 1. What if we had 2x squared minus x minus 1 equals 0? What did y'all do for that? A couple of ways to factor. One way y'all were told, did y'all multiply, and y'all might have done this last year, where you multiplied that 2 over,
Yeah, 8 times 6.
and you rewrote this to be 2x squared minus x. Oh, no, not the 2. Goodness gracious, sakes alive. It's just x squared because you multiplied the 2 over, right? So you have x squared minus x minus 2 Did y'all do that last year? Yeah? Don't remember? All right, let's try that. If we factor it this way, what can I multiply that gives me 2? Then I need to subtract and get a negative 1. Negative 2, so x minus 2, and then x plus 1. Now, what did I have to remember to go back and do after I've... Good. Absolutely. You had to come back and divide by 2, didn't you? And then you could set each part equal to 0 and solve. And that would give us what? X equals 1 or negative 1/2, right? We're going to do those same steps with this trig function, except for down here at the end, instead of saying x equals, I'm going to say sine of x equals. So let's walk through that process over here. If we multiply that 2 over, we're going to have sine squared x minus sine x minus 2 equals 0. Okay? Then we're going to factor this. And keep in mind, everywhere I had an x over here to the right, it's the same thing as having sine of x over here on the left. So it would be sine of x, and then sine of x. And what did we get inside the parentheses? Remember, we had minus 2 and positive 1. Y'all following? Good. Now we had to come back though and divide, didn't we? Because we multiplied over. So I have sine of x minus 1 times sine of x plus 1/2 equals 0. Now we're going to set each part equal to 0, so that means I have sine x minus 1 equals 0, sine x plus 1/2 equal to 0. So that tells me that sine of x is 1, or sine of x is negative 1/2. Okay, y'all look at that factoring. Does that look any different on the left than the right? It was the same process. Okay, y'all look at it and see, do y'all have any questions about it? Okay, now let's go look at the unit circle. Go look at the unit circle. So, let's see, this first angle probably is what? Pi over 2. Do y'all agree with that? Good, that's where your y coordinate is going to be a positive 1. Now over here, x is going to have to be what? Where are we going to get a negative 1/2? Should be the third quadrant, because sine is negative down there. What's it going to be? 7 pi over 6. Good. And what's the other one? 11 pi over 6. Good. Questions? Questions? Okay. All right, let's try another trig problem. Y'all got this? Got it? All right, let's do some more factoring. Okay, so again, let's try this one. We're going to have 2 cosine squared x, let's see, plus 3 cosine x. And then plus 1 equals 0. Okay. So what's going to be the first thing we need to do with this? Good, a times c. We're going to multiply this 2 over, aren't we? Same idea. So we're going to have cosine squared x plus 3 cosine x plus 2 equals 0. Okay, multiply b to c. No. 3 times 2. No, we're not going to multiply. Let's think about it being x squared plus 3x plus 2. Let's think about it that way. What would we do with that?
I'd see what multiply to 2 and then give you 3 out of it.
What can I multiply that gives me 2? 2 and 1, isn't it? Because I need to add those same two factors and come up with a positive 3.
Right.
So it's going to be x plus 2 times x plus 1, isn't it? Y'all okay with that? And we can even finish solving this and say, well, that's x equals, what is it going to be? -2, and x equals -1, but what do we need to come back and divide by? 2. So let's come back and divide by that 2. So x is -1. X is -1/2. But what did I start with? Did I start with x's? No. What trig function do I need to change x back to being? Cosine. So we have to set cosine equal to all this. So I have cosine of x is -1, or cosine of x is -1/2. Okay, so for one x value from the top, I bet that's going to be pi. I didn't forget it this time. All right, and then what about the other ones? Okay, somebody said 2 pi over 3. What do y'all think? Yeah?
Yes.
Look over in the second quadrant. Let's check ourselves and see. Look in the second quadrant. Look at 2 pi over 3. The x coordinate should be -1/2 if this is correct. Is it -1/2?
Yes.
Yep, so you know that one's right. Is there another one?
4 pi over 3.
4 pi over 3, because that's in the third quadrant, isn't it? Is that right? Okay. Questions about it? Any questions? Seems okay? Okay. Let's do another one. All right. Let's do one more. Woo, let's do one more. All right. This is going to be number 1 on your papers for today, what y'all are going to work on. You have cosecant theta minus cosecant squared theta plus 1 equals -1. Gonna add the 1. Yep. Let's give everybody time to get this written. It's all good. Okay, so we have cosecant theta minus cosecant squared theta plus 1, all equal to -1. Okay, and probably need to go ahead and add that 1 over, don't we? Y'all agree with that? So we have cosecant theta minus cosecant squared theta plus, looks like that's going to give me 2. Is that okay?
Yes, perfect.
Good. All right, now let's rearrange this because I don't want that squared term to be negative. I don't want that to be negative, do I? So if we added everything over to the other side, or we can flip all of our signs. Either one is fine. If I want to go through and say, well, I just want to multiply every part of this by a -1, you're welcome to do so. Because what is 0 times -1? It's still 0, and I'm going to be able to change all my signs this way. And I don't have to worry about going back and dividing through by anything. So if I go through and do that, notice, and I'm going to go ahead and rearrange also. That's going to make that negative cosecant theta positive cosecant squared theta. And then I'm going to have minus cosecant theta minus 2 equals 0. Is that okay? Because I changed those signs, and you can always flip your signs that way. Just make sure you change all of the signs, not just the first and last ones. Okay, if we thought about this as x squared minus x minus 2 equals 0, that's going to make it a little easier to factor, won't it? So if we do that, what can I multiply that's going to give me 2, but then I need to subtract and get negative 1? Negative 2 and positive 1, isn't it? So if I solve this, x is 2 or x is negative 1, but did I start with x? Nope. Nope. Got to go back and pull back in my trig function. So that's going to be cosecant of theta is equal to 2. Well, that looks weird. Do I have cosecant anywhere on the unit circle? No, I just have sine, cosine, and tangent. What is that the reciprocal of? Sine. So if cosecant is 2, what is sine? 1/2. Now, again, students are still trying to change the sign. A reciprocal does not change the sign of anything. It flips the number over. Does not change the sign. A lot of people are still saying opposite. Yes, opposite changes signs. But these are not opposites. They are reciprocal. So be careful with that. What about x equals negative 1? Well, that means cosecant of theta equals negative 1. Well, cosecant is the reciprocal of sine, so that means sine of theta. What's the reciprocal of negative 1? Still negative 1. Notice no sign change occurred there. You just flipped it over. Be super careful with that. All right, so what values, because it's a lot easier to look for these sine values, because I got those reciprocals here. So what would our theta have to be equal to? Where is sine of some angle 1/2? It's at pi over 6, isn't it? And pi over 3 pi, 5 pi, 5 pi over 6. Good. Do y'all agree? And what about where sine is going to be negative 1 at? 3 pi over 2. Are y'all okay with that? Y'all see what to do? Not really?
Wait, what are we looking for on what are we looking for? Negative 1?
Right, you're going to have two different ones. You're looking, whenever you get down to where I have all this boxed in.
I see you have the 1/2 up there. That was what I was getting on.
Oh, okay. You're good now? You're good? Anybody else have any other questions? No? Y'all good? All right, we have a sheet we're going to work on.